Hi everyone, welcome to our talk about the impact of AI on the backbone. Let me paint a little story here. So imagine you're on a beach in Australia, relaxing after surfing for a couple of hours. Your friend is in Costa Rica and she posts an Insta story about the sea caves that she has been exploring. You get a notification on your phone to see her Instagram story. You look at it and you like it. The question is, how is this possible in real time? Meta runs a truly global service due to the social nature of our products. My name is Jyotsna Sundaresan, and I've been at Meta for over 6 years working as a strategic network planner. I'm joined by my colleague Abishek, and we're here to share our learnings on the impact of AI on the backbone. Let me tell you a little bit more about Meta's backbone. Meta operates one of the largest backbone networks in the world. It's a global network that connects over 25 data centers and 85 points of presence. This is all possible because we have millions of fiber miles in both terrestrial and subsea routes, and with a backbone capacity that has grown over 30% year over the last 5 years. Now let's take a look at how AI impacts the backbone. So starting around 2020 is when we first started seeing demand for GPUs from our product groups like Facebook, Instagram, WhatsApp, etc. Now this demand was limited and it was asked for in small cluster sizes. Most of the traffic stayed within the DC or at most stayed within the DC region. However, starting 2022, we started seeing a whole different picture. The demand from product groups for GPUs grew over 100% year over year. And they were requesting for this demand in large cluster sizes. So similar to what we had seen in 2020 and 2021, we anticipated that most of this traffic would stay within the data centers. But that was not the case. We started seeing higher than anticipated growth in traffic on the backbone. And we were not expecting this. Our focus was only on one part of the AI lifecycle, which was reading data from storage to feed into the GPUs. Abhishek will talk a little bit more about our learnings about this end-to-end AI lifecycle. And there was a lot more to understand to truly characterize the impact of AI on the backbone. So in our talk today, we'll cover 4 main areas. 1, we'll talk about the AI lifecycle as seen through a backbone lens. 2, we'll talk about 2 main challenges from this AI lifecycle on the backbone, which is data replication and data placement. 3rd, we'll talk about how we solve these 2 challenges. And then we'll conclude the talk with some takeaways and a look ahead. I'll now pass it over to my colleague Abhishek to walk us through this AI lifecycle.
Thank you, Jyotsna. Hi, everyone. I'm Abishek Gopalan, and it's great to be here. I'm a network engineer, and I've been with Meta since 2017, working on our global network infrastructure, and I'm here today to share more of what AI has meant for our backbone. So let's get into it. What I want to share here today is what we characterize as AI lifecycle is truly important for us to understand to better manage our backbone network. So I want to take you through a few stages of what is part of this AI lifecycle. So let's talk about data ingestion. So this is often the first stage where you have data being generated by both users as well as machines. And this clearly has a lot of impact on the backbone because this data needs to shuttle many of our regions. And then we can talk about how this data actually is managed once it's ingested. And this involves what is often called as data preparation and placement. And as you can imagine, there are different pieces within this where there is persistence of data that is important, protection of data for reliability purposes, and freshness of data, all key aspects which have a big bearing on the backbone. And after that, I want to talk through what we often call as data replication. And data replicas, as you can imagine, would occur due to either popular content or AI-driven needs where we might need multiple copies of this data for training across our distributed infrastructure. And all of these have a big bearing on how the network needs to be designed and supporting these workloads. So after these three stages is when we really actually get into what is called AI training. And this is one where all the data is eventually shuttled to the compute infrastructure and the GPUs, and we're actually running training workloads. So this is a little bit of what Jyotsna alluded to earlier, where we really focused on this aspect and missed the bigger picture. And this is also why we want to share more about what this journey meant for us. So that stage in itself isn't actually very heavy on the backbone. It's really all of that that leads up to it. And finally, after AI training, we do have data going back again, potentially across regions to serve traffic and actually what is called AI inference. So while this is not as heavy as the data lifecycle that we talked through earlier today, this is a fast growing area that we're also paying close attention to. So let's look a little bit deeper into what these stages collectively meant on the backbone in the last few years. So our backbone has grown pretty significantly year over year, and let's pay a little bit of attention to the chart here on the right. So what we see here is AI and non-AI were at par a few years ago in terms of how much traffic they were driving on the backbone. But more recently, AI has not only grown faster, but also more in volume. And as you can also see, the yellow curve here is a lot more volatile than our non-AI driven needs. So this really sets us up to better dimension, plan, and design our long-haul network, our backbone network, to truly meet the needs of AI. And with that, I'm going to hand it back to my colleague Jyotsna to talk us through a few unique problems that AI has brought up on the backbone.
Thanks, Abhishek. Now let's dive a little bit deeper into this AI lifecycle that Abhishek just talked about. So we've always had to support movement of the data in the backbone, regardless of whether it's AI or non-AI traffic. So let's hone in on the first two steps that Abhishek talked about, which is data ingestion and data preparation. So let's look at the picture on the left, where you see new data sets in green that are constantly being generated either from users or from machines. Now, data consistency becomes key, especially given the global data collection. And now with AI, this volume of data increases as well. Data preparation, which includes making multiple copies of the same data, what you see in blue, the primary and the secondary copies. And third, the data persistence, which spans all the way from the freshest or real-time data that you see in green to the blue copies, which is the primary and the secondary copy in warm storage, all the way to the orange, which is cold storage. Now, I mentioned earlier that these steps in the data lifecycle apply to both AI as well as non-AI traffic. So then how does AI actually change things? There are three main things here. One, the need for fresh data. Two, more copies. And third, more volume of data. So we really start to see the impact on the backbone from the step 3 that Abhishek talked about, which is data replication. So let's look at the picture on the left. The green regions are the regions with data of interest, and they house copies of popular data sets. These data sets need to be moved to the yellow regions, which is where the training jobs have been set up. After the training jobs are complete, this data may need to move to the purple regions from which AI traffic can then be served. So again, with AI traffic, data over replication increases the complexity for three main reasons. One, high requirements for data freshness. Two, the number of times this data has to be moved between the green and the yellow and the purple regions. And three, the quantity of data that has to be moved, which is actually in the scale of exabytes. All of this we need to support on the backbone. And we do this through the millions of fiber miles in our network and terabits of capacity. Let's look at the second challenge from AI on the backbone. Now, this is related to data placement. So if you think about it, co-locating data and AI training in an ideal way is a very complex problem. So let's try to break it down and look at this from both a demand and a supply perspective. So on demand, what is happening is that product groups and the needs of demand are constantly evolving, especially in the AI world. For instance, with the Gen AI revolution, the uptick in short form video content and recommendations, we saw that not only the volume of demand that changed, but also the type of demand that our product groups like Facebook, Instagram were requesting was changing. Now, on the other side, where we're trying to stand up data center capacity or supply, we have constraints as well as volatility. And this comes from construction delays, changing geopolitical and regulatory environments, and rapidly changing market availability as well. So you have demand volatility, you have supply volatility. How can you get the data placement correct? How do you answer the question of when, where, how much, and what data needs to be placed? This becomes an optimization problem. You have dozens of product groups asking for capacity. You have multiple dozens of physical sites, each with multiple buildings. And you have dozens of hardware SKUs. So if you think about it, this leads to millions of variables and millions of constraints that you have to navigate before coming up with a placement plan. So first, we need to figure out what the physical hardware placement plan is going to be. Second, you have to figure out what the service placement plan is going to be based on where you've placed what hardware. Now, where AI adds complexity is that AI workloads are less fungible and they don't work as well with hardware heterogeneity. Now, as the upstream demand and supply changes, you're going to run into migration complexities as well. And migration is really hard because AI workloads are just not as fungible with hardware heterogeneity. So I talked about two main challenges from AI on the backbone, and now I'll hand it back to Abhishek to walk us through how we're solving them.
So, Jyotsna just shared with us some unique problems that AI brings to the table and how that translates to what it means for the backbone network. So now let's take a little bit of a deeper dive into how we've been approaching this and how we've actually come to address these challenges that AI poses on the network backbone. I want to share a little bit about what we often refer to as bending the demand curve. So as you can imagine, and we talked about some of these trends, AI has put a big stress on the backbone. So we're always looking for opportunities to actually bend that demand curve so that we're efficient in how we deploy the backbone while still meeting the needs of AI and all other workloads. So one of the key lessons we've come to learn in the last few years is that it often takes a holistic view across the stack, both compute, networking, and storage, as we've talked about data lifecycle, and it's really that holistic view and global optimization that makes for best decision making. And we often lean on rubrics like total cost of ownership and efficiency to really understand and do the right thing for infrastructure as a whole. Now, with that said, let's take an example of what this means or how this looked like. And I want to walk you through a specific example of where we were looking at what fresh data would drive on the network. And this was one of our big blind spots early on in our AI journey and something that we've come to learn more on. So let's dive into that. So I want to walk you through this chart on the right here. So what that is really telling us is specifically for this use case of shuttling fresh data for the needs of AI training across our backbone. Earlier in time, even as it stood, the compute costs were actually starting to get dwarfed by the network costs on the backbone. And that's what the pie chart is really showing us. Now, from that point on, when we started looking at projections and how or what this would manifest and grow into over time, and that's the yellow curve there at the top, and this is without any efficiency efforts on the backbone or storage or data placement, we would be looking at a significant growth on the backbone. And this is one where most of our cross-region reads for this data were actually happening directly on the backbone. And so with that actually really got us thinking, how better can we serve this while still meeting the needs of our workloads? And that has led to us developing significant efficiency efforts and data caching and placement algorithms, where what we're really looking to do is ensure that we can still get that fresh data, but we're not actually over-indexing the usage of backbone. And so we would deploy caches at different regions so that you're not actually going cross-region if you already had that data in a region. And this has already helped us bend the demand curve from that yellow down to the blue. So something that was looking like over 95% of reads going cross-region we are already able to get that down to about 60% due to better caching and data placement. And looking further, we have more opportunities and room to further look at more intelligent algorithms that can further bend this demand curve all the way with goals of getting this down to 15% in the long run. So let's take a step back from that specific example where we really need to look across the stack. And I do want to paint a little bit of a picture on the overall backbone where we've built and operated a quality of service framework to offer a truly differentiated service for various workloads that run on our backbone network. And we double down and lean on that heavily for AI as well as other workloads so that we can right size and custom fit different use cases. And this has helped us tremendously to keep demand in check. And in addition to that, we've also deployed solutions where we lean and leverage temporal opportunities. As you can imagine, there may be workloads that don't necessarily need the latest and greatest data, or they may be more delay tolerant. And we lean on all of this and work across our partner teams to actually make better, efficient use of the backbone. So that hopefully gives a little bit of color on what we've been doing on the backbone to address some of the challenges Jyotsna talked about. And there's always room to do more here, and we're looking at a lot more opportunities and how we could better place data and that is aware of network, compute, and storage altogether, which is really the key theme I want us to take away here. Now, with that said, this is really talking about some of the efficiency efforts we've done, and we've done many others. This is just one example I wanted to share. There are ones where we've looked at reducing the copies of data that Jyotsna talked about, which is the over-replication, making sure we're actually shuttling data that is useful and not that doesn't go unused. So with that, I want to flip gears a little bit into the other side of this equation, which is really about opening up our supply curve. And what does that mean? Let's look at that. So we really want to stay ahead as network infrastructure to make sure we can support the needs. So we've built purpose-built AI training capacity, and this again is a different flavor of how we've had to look across the stack. This isn't about the services themselves, but also across physical infrastructure such as power, cooling, and network. And we have to make decisions across the stack to make sure that we can enable our workloads and product needs. So really what we mean by this is, if you just kind of look at this logically, we want to make sure we can meet that same demand in a more efficient manner by bending the curve for demand while also opening up supply. And why do we want to do this? So this, as you can imagine, really allows us to unblock product innovation, which isn't always something we may know upfront. And there is a lot of experimentation and ideas going on. And there may be innovations that are showing up at a much more rapid pace than what infra can kind of meet. So we always want to stay ahead so we don't block our product innovation. And similarly, there may be other inorganic growth needs. And finally, I want to touch upon another aspect or angle and maybe talk through a couple of examples here. So we've seen cases on our backbone network where, in spite of the best optimizations, as Jyotsna talked through, the complexity of that multidimensional problem of data placement and storage can often lead to fragmented compute, storage, and data. And when this happens, sometimes it might be the right call to actually pivot to using more network liberally, which might be the overall right thing to do for infrastructure. And a specific example is one where we've allowed inference workloads to actually go cross-region to ensure that if you don't have the right computer data in region, it would still be okay to use the backbone in this particular case, and it turns out net positive from a TCO angle. And we might look to do this in a more contained fashion, say in specific geographic zones, so that this also has the benefit of better latencies while also making better use of our compute infrastructure and not actually fragmenting or stranding them. So it's always this holistic view that we've often had to take, and network is one key part of that big puzzle that we're always looking to solve and do better. And with that, I want to hand us back to Jyotsna, who's going to help wrap for us. Thank you.
Thanks, Abhishek. So what did we learn today? We thought that the impact of AI on the backbone was going to be small. But data replication, placement, and the requirement for fresh data has a large impact on the backbone. But the thing is, there's still a lot of lessons to be learned. We don't know what the impact of large clusters is going to be. Gen AI, AGI, all that is yet to be learned. All of this is happening at a very high speed and a rapid rate of innovation This is an extremely exciting time to be at Meta. So join us on this journey ahead. I'll leave you with the last closing thoughts. The next time you see your friends' Instagram stories from across the world and you feel this sense of closeness as though you're sitting shoulder to shoulder, sharing your lives, think about how all of this is possible because of Meta's backbone. Thank you.